All right, friends, believe it or not, I am filming the final video in the special topic series. This is special topic number 14, titled Anything Goes. And truly, anything goes when it comes to the College Board exam recently. In recent years, the College Board has had at least one, maybe two of the 6 free response questions every year where it is just a mix of all sorts of different skills, not just one particular skill or a focus area like rate functions and area and differential equations, but now everything getting mixed in together. I wouldn't expect that to happen on all 6 questions, but 1 or 2 of the questions, very likely. And your job is to just stick the landing, do the best that you possibly can with the time that you have, and don't get too freaked out. So here we go. I'm going to start with a kind one first. This is on page 88. This is from the 2011 exam. This is question number 6, which means it's calculator inactive. This would have been the last question that you saw on your exam. So think about this. You've already been testing for over 3 hours when you come across this question. Okay, let f be a function defined by f of x equals 1 minus 2 sine of x for values of x less than or equal to 0, and e to the negative 4x for values of x greater than 0. Show that f is continuous at x equals 0. Well, that's not too bad. Remember, it's a 3-step process. Find f of 0, show that it exists. Find the limit as x approaches 0 of f of x, show that that exists. And then make sure that f of 0 and the limit as x approaches 0 of f of x are the same. If any of these 3 conditions is not met, then the function's not going to be continuous. Well, f of 0 means evaluate the function at 0. I'm going to look at this. If x is equal to 0, I'm going to use 1 minus 2 sine of x. So f of 0 is equal to 1 minus 2 times sine of 0. Sine of 0 is 0, times 2 is 0, you get 1. Okay, not bad. Now I want to look at the limit as x approaches 0 of f of x. And remember, in order for the limit as x approaches 0 to exist, especially when you're talking about a piecewise function, you need to find the limit as x approaches 0 from the left and the limit as x approaches 0 from the right. If you are approaching 0 from the left, that means numbers smaller than 0, then your function is 1 minus 2 times sine of x. If you're approaching from the right, that means your values of x are greater than 0. That's going to be e to the negative 4x. To evaluate these limits, one of the things that we want to do first is try direct substitution. Basically, can you plug in? You get 1 minus 2 times sine of 0, which we've already know is 1. If I try direct substitution with e to the negative 4x, you get e to the 0, which is 1. These values are the same. I'd say, therefore, limit as x approaches 0 of f of x exists. Since f of 0 is equal to the limit as x approaches 0 of f of x, this means that f of x is continuous. Now be careful here. Where is f continuous? At x equals 0. Okay, so you were awarded 1 point for considering the limits from the left and the right, and then 1 point for your conclusion. This is a total of 2 points, and really not too bad at all. I would expect most students are going to earn almost all the points here. You've got to be careful though, because a big mistake students make is they'll say, since f of 0 equals the limit as x approaches 0, f is continuous, and that's too strong of a statement. You've only shown continuity at x equals 0, so you want to be careful there. All right, enough of that. Let's move on to part B. Part B, for x not equal to 0, express f prime as a piecewise defined function. Find the value of x for which f prime of x is equal to negative 3. Well, what do we know? We know that f is 1 minus 2 sine of x for x less than or equal to 0, and e to the negative 4x for x greater than 0. If they want me to find f prime is just going to be the derivative of each piece. The derivative of 1, that's a constant, is 0, minus 2 times the derivative of sine of x is cosine of x, and that is true for x less than 0. I'll come back to that in a second. The derivative of e to the negative 4x is going to be e to the negative 4x times negative 4 because of your chain rule, and that's true for x greater than 0. Now you might be asking yourself the question, what about differentiability? What about the derivative at x equals 0? Well, because you've got a piecewise function that is defined one way for values of x less than or equal to 0, and a different piece for x greater than 0, you would actually have to evaluate the derivative from both the left of 0 and right of 0 to see if the derivative is actually defined. You're not being asked to consider x equals 0. They're being kind. So you only need values for x less than 0 and a derivative for x greater than 0. Okay. Find the value of x for which f prime of x equals negative 3. Well, if f prime of x equals negative 3, I don't know which piece of the derivative I'm supposed to be using. So I have to consider both. So I'm going to set up the equation, negative 2 cosine of x equals negative 3. I'm going to set up the equation, e to the negative 4x times negative 4 equals negative 3. And I'm going to solve both of these for values of x that make this equation true. If I divide both sides by negative 2, you get cosine of x equals 3/2. Now 3/2 is greater than 1, and one of the things you need to remember about the cosine function is that the maximum value for the cosine is 1. It can never ever be greater than 1, so this part over here has no solution. On this part, if e to the negative 4x times negative 4 equals negative 3, we'll divide both sides by negative 4, and you get e to the negative 4x equals 3/4. Your goal is to solve for x, so to do that, we're going to take the natural log on both sides. We do that because the natural log of e to the power, the natural log and e are inverses. You just get negative 4x equals natural log of 3/4. To solve for x, you're going to divide. So natural log of 3/4 divided by negative 4. Or, of course, you could have written this as negative 1/4 natural log of 3/4. Lots of options. Now, look at the points here. 1 point for the derivative of the first part, 1 point for the derivative of the second part. I bet just about everybody had these right away. And then 1 point for coming up with the solution of x equals negative 1/4 natural log of 3/4. That's 3 points. And those are all really skill-based questions. So was A. So A, do you know how to show a function is continuous? B, can you handle finding derivatives of a piecewise function? Let's see what they have in store in part C. In part C, we're told to find the average value of f on the interval, negative 1 to 1. Okay, a quick recap here. Average value of a function on an interval AB is found by integrating the function from a to b and then multiplying by 1 over b minus a, or some teachers like to write it the integral from a to b f of x dx divided by b minus a. Either way means the same thing. Well, what's going on here? I want the average value of f on the interval negative 1 to 1. So that means integrate from negative 1 to 1 f of x dx and divide by 1 minus negative 1. Well, that's not too bad, except you've got a piecewise function. f of x is defined differently for values of x less than or equal to 0 than it is for values of x greater than 0. So what we're going to have to do is we're going to actually split this integral into two. We're going to integrate from -1 to 1. We're going to integrate the function 1 minus 2 sine of x with respect to x, because that's how f is defined on this interval. Plus, we're going to integrate the function e to the negative 4x with respect to x from 0 to 1, and this whole expression gets divided by 2. Now, for those of you that are a little worried about x equals 0 being used as your upper limit here and the lower limit here, that's okay. That's okay. Your graph is defined to be 1 minus 2 sine of x for x less than or equal to 0. We have continuity of the function at x equals 0, and then you've got e to the negative 4x picking up at x greater than 0. So whatever your function looks like, this is not meant to be a sketch of the true function. But let's say the function looks like that. And that's not what I meant. Sorry. My bad. My bad. Awkward. Say your function looks like this. It does one thing until you get to 0 and another thing after you get to 0. You're being asked to integrate from -1 to +1, which is an area computation. You want all this area. What we're doing here is we're saying find the area from -1 to 0. So this is region number 1. Find the area from 0 to 1. That's region number 2, and add the two together. Well, isn't that the same thing? All right, let's keep going. We're going to integrate now. And since we've already done that video, I'm going to go a little fast here. The integral of 1 is x. The integral of -2 sine of x is 2 cosine of x. You evaluate from -1 to 0. Plus the integral of e to the negative 4x is -1/4 e to the negative 4x from 0 to 1. Still dividing everything by 2. To evaluate an integral, remember big parentheses minus little parentheses, 0 plus 2 cosine of 0 minus -1 plus 2 cosine of -1 plus big parentheses minus small parentheses, -1/4 e to the negative 4 minus -1/4 e to the 0, the whole thing divided by 2. That's it. I'm sure you can simplify if you want to, but what a waste of your time. So here's how the College Board awarded points. They awarded points for knowing to break up this integral as two separate integrals. They awarded a point for the antiderivative of the first piece, another point for the antiderivative of the last piece, and then 1 point for reaching here where everything is a number. So that's a grand total of 4 points. Personally, I really like this question. I think it's a relatively kind question where students are just being given an opportunity to demonstrate the various calculus skills that they've developed over the course of a year. Now we're going to switch gears and look at an unkind question. Okay, here we go. Where did I leave it? All right, I'm on page 87. This is known as the funnel question. All right, so let's keep going. This next question is rough. This is a really, really rough question. This comes from the 2016 exam. It was question number 5, which means it's calculator inactive. And to be honest, I was filming this question. I did part A, and I made a mistake. I did part B, and I made a mistake. So I'm coming back around to redo this problem. This is a really tough question, so brace yourself. Okay, the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r equals 1 over 20, 3 plus h squared, where 0 is less than or equal to h, less than or equal to 10. The units of r and h are inches. Okay, so what I know is that the radius is measured in inches, the height is measured in inches. At any point in time, the height is determined by, the radius is 1/20th of 3 plus h squared, and that's true for 0 less than or equal to h less than or equal to 10. Okay, and the funnel has a height of 10 inches. That's what I know. All right. In part A, find the average value of the radius of the funnel. Well, we just did a question on average value. How do we find average value? Well, you want the average radius, so you're going to integrate the radius. The radius is a function of the height, so I'm going to integrate with respect to h. The height varies from 0 to 10, so I'm going to integrate from 0 to 10. And you're going to divide by 10 minus 0. This was mistake number 1 for me. I forgot about dividing. Okay, well, what do we know? We know that 10 minus 0 is 10. To divide by 10 is the same as to multiply by 1 over 10. The radius is a function of the height, so that's 3 plus h squared with respect to h. And there's a 1 over 20 in there, isn't there? Told you, tough question. That 1 over 20 is a constant that I'm going to pull out in front. 1/10 gets multiplied by the 1 over 20 to give you 1 over 200. The integral from 0 to 10 of 3 plus h squared with respect to h. The integral of 3 plus h squared with respect to h is going to be 3h plus h cubed over 3. We're going to evaluate from 0 to 10, and we're going to multiply by 1 over 200. Okay, well, to do that, I'm just going to plug in 1 over 200, 3 times 10, plus 10 cubed over 3, minus 1 over 200, 3 times 0, plus 0 cubed over 3. There is no need to simplify. That is just foolishness. But if you wanted to, maybe you just want to get some practice with simplification, that's fine. Don't do it on the free response. The average is going to be 109 over 60 inches. In terms of points, they awarded 1 point for the setup for the average value, 1 point for finding the antiderivative, and 1 point for getting to the numerical answer, either the unsimplified version or the simplified version, for a grand total of 3 points. Not too bad. I saw some students who did pretty well with this. Let's keep going though. Part B. Oh, my bad. Okay. In part B, we're asked to find the volume of the funnel. And I think this is where kids started to fall apart. How do you find the volume of this funnel? They didn't give you the volume formula. The only volume that we've done in this course has been volume of revolution and volume with known cross sections. Well, you could apply either technique here. Imagine your cross section. They told you your cross section is going to be a circle. That circle has a particular radius. The height of that little cross section is what we're going to refer to as dH. So if I wanted to find the volume, what I'm going to do is I'm going to integrate from 0 to 10 the volume of these circular cross sections. How are you going to find the volume of a circular cross section? Well, it's going to be pi times your radius squared times the height, which is dH. We know that r is 1/20th of 3 plus h squared. We also know that the pi is a constant, so I'm going to pull that pi out in front. pi the integral from 0 to 10, 1 over 20, 3 plus h squared, squared, dh. Now, you are going to have to integrate this. And this integrand is messy, and so some of you might be thinking, oh, I know, let me do u substitution. And that's not a bad idea, but it's not going to work here. If you tried, you'd probably say u is equal to 3 plus h squared, but then the derivative of u is 2h. If this is what I'm calling u, I don't have any multiple of h left in the integrand, so it doesn't get me anywhere. What you're going to have to do is actually multiply this out. So imagine 1 over 20 times 3 plus h squared squared. That means 1 over 20 times 3 plus h squared times 1 over 20 times 3 plus h squared. You're multiplying 1, 2, 3, 4 terms together. The nice thing is in multiplication order doesn't matter. So I can multiply the constants, 1 over 20 times 1 over 20, 1 over 400. 3 plus h squared times 3 plus h squared. If you need to, and I think it's a good idea, go over on the side and do your little box. 3 times 3 is 9. 3 times h squared is 3h squared. H squared times 3 is 3h squared. H squared times h squared is h to the 4th. You get 9 plus 6h squared plus h to the 4th. This is your integrand. It's not your answer. So where are we now? Volume is pi, the integral from 0 to 10, 1 over 400, 9 plus 6h squared plus h to the 4th, integrate with respect to h. That 1 over 400 is a constant. I'm going to move it out in front. Pi times 1 over 500 is, 1 over 400 is pi over 400. Integrate from 0 to 10, 9 plus 6h squared plus h to the 4th dh. The pi over 400 stays right where it is. The integral of 9 with respect to h is 9h. The integral of 6h squared with respect to h, add 1 to the power, and divide, so now you have 2h cubed, plus the integral of h to the 4th, add 1 to the power, and divide 1/5 h to the 5th. You're going to evaluate from 0 to 10. Plug in the 10, pi over 400, 9 times 10, plus 2 times 10 cubed, plus 1/5 times 10 to the 5th, minus pi over 400, 9 times 0, plus 2 times 0 cubed, plus 1/5 times 0 to the 5th power. That is your final volume. There is absolutely no need for you to simplify. If, however, you decide you want to get some practice, this will simplify to 2,209 pi over 40, and the units will be cubic inches. In terms of points, they awarded 1 point for the integrand, the 1/20th 3 plus h squared, the whole thing squared. 1 point for finding the antiderivative, and 1 point for the numerical answer. Again, unsimplified or simplified. In the middle of the AP exam, there's no way. There's no way I'm even going to think to simplify. I'm just going to leave it and move on. That was worth 3 points. And I'll tell you, that was a tough, really tough 3 points to pick up for kids. All right, last question in the home stretch. Part C. The funnel contains liquid that is draining from the bottom. At the instant when the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay, hold on a second. The funnel contains liquid that is draining from the bottom. Okay, we are losing liquid. At the instant when the height of the liquid is 3 inches, h equals 3 inches. The radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. What that's telling me is dr dt. dr dt is 1/5 inch per second, but it has to be negative because we're decreasing. At this instant, what is the rate of change of the height of the liquid with respect to time? What is dh dt at the time when h equals 3? That's what we're after. Okay, so we know dr dt, we want dh dt. Well, what do we know? We know that r is equal to 1/20 times 3 plus h squared. They gave me information about how the radius changes with respect to time. They want information about how the height changes with respect to time. This is a related rates question. Related rates means find the derivative, okay, with respect to time. Well, how does that work? The derivative of r with respect to time is dr dt. The 1/20 is a constant that you're multiplying by, so we leave it alone. Derivative of 3 is 0. The derivative of h squared with respect to t is 2h dh dt. Let's see, they told me dr dt, negative 1/5. We've got 1/20th, 0 plus, I didn't need to write the 0, sorry about that, 2 times the height is 3, we need dh dt. So negative 1/5, 1/20 times 6, dh dt. To solve for dh dt, we can multiply both sides by 20. 20 times negative 1/5 is negative 4. 20 times 1/20th is 1. So we get 6 dh dt. Divide both sides by 6 and you get negative 4/6 equals dh dt, or of course dh dt equals negative 2/3. What are the units? H is your height, that's measured in inches. T is your time, that's measured in seconds. So this is the rate that the height changes with respect to time when h equals 3. Your height's decreasing, which should make sense since you have water leaking out of the bottom of the funnel. In terms of points, 2 points were awarded for finding the derivative, and then 1 point for coming up with the rate, for a grand total of 3 points. And quite honestly, this one's not too bad. I would hope that a lot of my students would earn points here, but my fear is that Part B was so rough for them that they gave up, they just kind of lost confidence in themselves, and hopefully they moved on to question number 6. But I don't know for sure. Guys, this is the end of the all the videos that I've filmed for the special topics. I hope you have found them to be helpful. I've really enjoyed doing this. It has definitely been a labor of love. Watch the videos as often as you need to between now and the AP exam. Share them with your friends. Encourage them to watch it. I want to see everybody boost their scores. Best of luck. Bye.